So when talking about evolution, we talk a lot about natural selection and artificial selection. We talk a lot about all these different pieces of how they play together, how we track it, but we're going to specifically focus in on those evidences for evolution. So we've talked about most, if not all of these already, but we just want to really focus in and make sure that we know that these are our evidence from evolution. This is where we get that understanding that we have. So we're going to talk about 4 widely accepted forms of evidence for evolution. So there are more than 4, but these are kind of the big 4, right? So our first one is comparative anatomy. So comparative anatomy is going to analyze different structures. So the first type is going to be homologous structures. So these are structures with a similar structure, which I know is repetitive, but it basically means that it's front limbs that have a similar anatomical makeup, right? So if you've got humerus, radius, ulna, carpals, metacarpals, you've got that same physiological, that same anatomical structure. But they have different functions, right? So if you think about the structure of your front limb, of your arms, it is extremely similar to the function of a bat's, or to the structure of a bat's wing. So bats have these same bones in the same order, but just like they don't use their hands to grasp, you don't, or they don't use their wings to grasp, you don't use your hands to fly. So similar structure, different functions. All right, so from homologous structures, we're moving on to vestigial structures. So these guys are going to be evolutionary leftovers. So they're remnants of once useful organs which indicate a common ancestor. So what that means is these are things that are left over from our evolutionary past. So a great example of this is like a human tailbone, because while you do not have a tail, you do have a tailbone, which is where long ago we had an ancestor that did have a tail that connected to that tailbone. All right, and finally, we're going to talk about analogous structures. So that prefix a means not, right? So in the same way our prefix homo means same, right? Our prefix a means not. So these are going to be structures that are not the same. So they're similar in function, but different in structure, right? And they can be analyzed, but they do not indicate common ancestry. So this is really helpful if we're looking at divergent evolution. So evolutionary branches that went different ways. So if we look at the fin structure of, say, a shark and a dolphin, both fins, both used to swim, both help steer in their water, but they're evolutionarily very different. Their structure, their makeup is very, very different. Sharks don't even have bones in their fins. It's all cartilage, versus dolphin fins have the same bone structure as your hand, because again, we're all coming from that mammalian ancestry. We're all mammals. So our next form of evidence for evolution is going to be fossils. So this is one we've talked about before. So remnants of organisms that once lived, if we think about like that cast fossil and those trace fossils. So this is going to tell us information like diet, geographic location, and the time in which an organism lived. So that's hugely helpful because it literally just tells us like the animals went in this order, right? So these things are going to be used to determined using relative dating, which gives us an approximate time period relative to the other layers of the Earth. So we know it's younger than this, older than this. If it's above the KT extinction, it's younger than 65 million years, so on and so forth, right? And absolute dating, which gives us more of an exact time period by using those radioactive isotopes. So irregular number of neutrons is going to cause them to decay. They shoot off those alpha beta particles, boo, 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 right? And when they do that, that is going to allow us to measure that half-life, the amount of time in a half-life, and that's going to help us to figure all those things out, to determine exactly how old that fossil is, or at least get very close. All right, our third form of evidence is embryology. So this is the study of unborn animals at a very early age. So right after egg fertilizes sperm, develops into the embryo. So this is before you're even a fetus. And this is considered evidence of evolution because of these similarities of very different organisms. So fish embryos, human embryos, chicken embryos, basically everybody looks really similar right after we've passed that egg and sperm stage. So that similarity between embryos helps to show a common development, which helps to show common evolution. All right, and finally, we've got biochemistry. So this is possibly the most powerful form of evidence for evolution. So nucleic acids, including the most famous DNA, deoxyribonucleic acid, and RNA are analyzed for the similarity between organisms. The more in common, the more closely related the organisms are believed to be. So the more of your DNA and RNA you share, the more similarly related you are. So you share an overwhelming amount of your DNA with like a chimpanzee and a bonobo chimp, but you still share a good amount of your DNA with things like trees and bananas because a good amount of your DNA just helps to make you a living thing.